a column on the right-hand side of that orange sheet, and then you're going to have f primes in there. There's probably not enough space to do it all. So what about the next one? If the derivative of the natural log of x is 1 over x, then what's the derivative of the natural log of f of x? 1 over f of x times f prime of x. It's really not bad. The one that's bad are the other base logs. Check. Times the derivative of x. Yes, it is. But that's 1. Pardon? They're all over there. You'll have to find them. This is just reviewing yesterday. Okay. Now we're going to do the log base. Let's make it a, actually. I'm going to make this an a. Okay. Okay, guys. I never remember the other kinds of logs. Well, I'm getting better, but I've only been doing this 20 years. So I don't memorize it. I take this log base a of x, and I'm going to rework it. So y equals log base a of x. Now, I do know change of base, Jack. What is the change of base? I know the derivative of natural log. So why don't I write this as natural log of x divided by the natural log of a? It's the same as this, log base e of x over log base e of a. Except we write it ln because we do it so often. Otherwise, you'd have to write it. If you don't see a number here below the log, then it's always base 10. Okay, Jack, question? Now, I want to take the derivative of this with respect to x. So it's d dx. Now, what's true about the log of a? That's just a what? It's just a constant. What's the derivative of a constant? No, it's 0. So I can use the product rule if you want. I can use the quotient rule if you want. Doesn't matter. But why don't I just ignore that? Why don't I just make that dy dx on the left side is 1 over the natural log of a times the derivative with respect to x of the log of x. And if you want me to go further, I can say then it's plus the log of x times the derivative with respect to x of 1 over the natural log of a. But what is that derivative? What is that? It's 0. Kind of looks like a 0. Okay, so let's finish this. And I do a change of base. I use the product rule. I could use the quotient rule, but the log of a is always 0, the derivative. So what's the answer? It's 1 over the natural log of a times 1 over x. Now, I memorize it because, Jack, don't do that, please. Because I get it confused with the derivative of a to the x. Where is that log of a? So I have that one memorized, and I do a change of base if I get something other than base e. I'm proving to you why it is what it is. If you memorize it, you're fine. If you can keep the log of a in the right place. So you try the next one. I need to go down. Okay. So this is going to be equal to, look at the patterns. This was, the derivative here ended up being, let's clean it up a little bit, 1 over the natural log of a times 1 over x. So what's this going to be? 1 over the natural log of a. And if it were base e, it would be the natural log of e. But what is the natural log of e? 1. Times 1 over whatever's in there, which is f of x, times the derivative of f of x, which is f prime of x. I believe that I have the solutions to this online.
So do we have to memorize like all these?
Yes, and you're going to have to memorize at second semester the bottom half. And that's it. Those are all the derivatives and integrals you know.
So we have to know the top two by tomorrow.
You have to know all but the bottom three
Oh, the top two?
of this top half, yeah. You don't have the inverse sine or cosine yet. Yes. I did because I wrote this as 1 over the log of a times the log of x. This one? Oh, on the salmon sheet? Which one? F of x to the n? That one? F of x. Now, to the n, that's the power rule. So you do the outside, n, f of x to the n minus 1 times the derivative of the inside. And then you can do that times the derivative of x, if you'd like. Was there another one on here that you wanted? Make that a b where you see log of a. It's right here. That you finish that up. Hand out today's lesson. I don't believe logarithmic differentiation is on the AP exam, but you get great practice on some of the other things. Okay, you guys, we're going to do what they call logarithmic differentiation. And it's a kind of a trick. Actually, let's go back to my other page and let's do another problem. I think I'll add it. Remember when we did y equals a to the x or 2 to the x? Now, do you see the difference between that and the power rule? A to the x is an exponential. The exponent is the variable. X to the a is a power, where the base is the variable. Okay, Jacob? Okay, so that's the difference. So this is an exponential, has a different rule. We did that, and I said, you know, what we did yesterday was we said that this was equal to e to the natural log of a to the x. And you guys weren't real comfortable with that. I'm not real comfortable with that. So instead, I'm going to do what we call logarithmic differentiation. I'm going to log both sides. Now, if there's a sum here, I don't want to do that. But if it's times, I'm okay with it. And so I'm just going to clean that up a little bit. I only use this as a last resort. So it's the natural log of a to the x. Then we have some properties, Noah, of exponents. We have the natural log of a times b. What's that equal to? It's log of a plus log of b. No factoring. What's the log of a divided by b? Okay, log of a minus the log of b. So when you do the homework problems, it's usually, if not always, easier to use properties of logs to simplify what you're doing than it is to just take the derivative the way they give it to you. Okay, one more. What's the log of x to the r? R times the log of x. Notice I use all natural logs because that's honestly what we'll be using. So I can take this exponent here and put it in front. So I get the log of y equals x times the log of a. Yes, it's right here in your handout. Oh, turn it over. I'm doing an easy problem, then I'll do the hard problem. Now, I haven't taken a derivative yet. We're going to do that. It's with respect to x. And what is the derivative of the log of y, but with respect to x? Well, that's my function. It's a chain rule. So it's 1 over what? Y times the derivative of the inside function, which is dy dx. This is called logarithmic differentiation. I log both sides, then take the derivative implicitly. And remember how we started with implicit? It was hard. Okay, so think of this as the log of f of x, then the derivative, I have to be careful in notation, is 1 over f of x times f prime of x. Because we just did that over here, remember? The derivative of the log of f of x is 1 over f of x times f prime. It's the chain rule. Well, but you know what? That's y, isn't it? Isn't f of x just y? And isn't f prime of x just y prime or dy dx? Now, here's the part that is going to bother you. What's true with the log of a? Is it a variable? No, it's a constant. So can you pull the constant out? Yes, remember? The derivative with respect to x of some constant times f of x is equal to the constant times the derivative with respect to x of f of x. Sure you can. So I'm going to pull the log of a out and then multiply by the derivative of x. What's the derivative of x? 1. If you wanted to continue and use the product rule, and I didn't leave myself any room here, but then I would have x times the derivative of the log of a. What's the derivative of the log of a? It's 0. Because you guys want to do the product rule. So what's going to happen to this term?
Why did you do the product rule there?
Because that's a product. But I could just pull the log of a out, which is what I did. But for those of you who want to take the derivative of the log of a, go ahead. It's 0. It's not 1 over a. It's a constant. Log of a is whatever. It's just some number. I don't know what it is. As long as it's not log of x, some variable. Correct. Log of a is a constant. So now if I solve for dy dx is equal to y times the natural log of a. And if I scroll back up, Jacob, I can find out what y was, because I've forgotten all that after all this. What was y equal to? A to the x. So this is equal to a to the x times the log of a. I didn't do it this way yesterday. I did it a different way yesterday. I made it e to the ln of a to the x, and you guys didn't like that. That's okay. Take your pick. You're going to memorize it anyway.
So we don't have to show all that.
No, you just memorize it. This is showing you why it is what it is. I started off yesterday with the derivative of e to the x and why it is what it is, and then went from there. Okay? That's all you can do. That's logarithmic differentiation. So now if you turn your sheet, so it's the top half there, I want to do this problem. I want to find the derivative of y. It looks complicated, doesn't it? Does it look complicated? I'd have to use the quotient rule, and then I'd have to use the chain rule, because there's composite functions there. Or I could try and see if I can make it into a simpler problem by using logarithms. So I'm going to log both sides. So I want to take the log of y and the log of this. Well, I don't have a lot of space here. So let's just use our properties of logs right away. So on the left side, I still get the log of y, no derivative. Now, this is the log of a over b. I'm only going to use natural logs. We're never going to use any other basis. Okay, what's the log of that quotient? Want me to write it again? What is the log of a divided by b? It's the log of a minus the log of b. So this is the log of, I want to simplify this. And honestly, you have to do it on a lot of the problems in the homework. Nope, I'm going to do this with logarithmic differentiation. And it's the natural log of this. You'll see what's going to happen in a moment. I could do it with the chain rule, or I can make this an easier problem by using properties of logs. There's more things I can do. What can I do with that 5? Put it out in front. This is equal to 5 times the log of 3x squared minus 4. What about the 3 over here? I can pull that out in front. Minus 3 log of negative 2x minus 5. Can I distribute the logs across a sum or difference? Can I make that the log of 3x squared minus the log of 4? No. That's it. The only way I can make this equal to a sum or a subtraction is this has to be a product or division in there. So now let's take the derivative. And this is easy. I'm still going to have to use the chain rule, but it should be easier than doing the original problem. And then sometimes I have no choice. Now, I'm going to pass it right through that 5 because I can, because that's a constant. You can always pull the constants out. And what's the derivative of the log of y? 1 over y times the derivative of the inside function. Okay, Sarah, is that okay? Times dy dx equals 5. Now, the derivative of this is easy. Well, if you did the homework, it should be easy. What is that?